Assalamualaikum and very good morning. Hi everyone. Today we will study about fresh concrete. As it names, fresh concrete is a state after the raw material has been mixed and before your material becomes solid and hardened concrete. So let's say over here we have the four materials of concrete. These materials will undergo a complete mixing process to form a hardened concrete. So the fresh concrete is the state in between these two processes. Okay, so if I can list down over here, we have raw materials and then undergo mixing process, they become fresh concrete, and after the fresh concrete has been cast and already mature enough, it will harden and can be released from the formwork. So what are the requirements for fresh concrete to be called as a good fresh concrete? The first one, it should be easy to be mixed, to be cast, to be compacted, and to be transported. The next one, the fresh concrete should be uniform in every part. You cannot have like a fresh concrete where in certain part they are dry and the other part is quite wet. Or in the one part, there are only fine aggregate and coarse aggregate without any coat of cement paste, while the other part, they have enough coating of cement paste. The next requirement, it should be flowable. So your concrete must be able to flow into a very narrow gap. Gap over here in terms of the distance or the spacing between rebars. I will give you an example over here. Okay, this is one example of slab reinforcement. When you're pouring your concrete onto the formwork, your fresh concrete must be able to seep into the space between the rebar. So that's why one of the good characteristics of the fresh concrete, it must be flowable, especially to seep into the narrow gap or narrow spacing between the rebar. The next requirement, your fresh concrete must be easy to be compacted. In this example, you can see the narrow and tall dimension of a load-bearing wall. So when the worker is pouring the concrete into the formwork, the worker must be able to compact the fresh concrete, particularly in every section of the wall, perfectly, regardless of the position at the bottom, at the middle, or at the upper part of the load-bearing wall. What happens if you cannot compact the fresh concrete, especially in the narrow spaces? I will give you the example in the next requirement. In number 5, your concrete must not easily segregate. What is segregation? Segregation is the separation between coarse aggregate and fine aggregate because there is insufficient amount of cement paste to bind or to combine them together, and finally you have a lot of pores as shown in this picture. This is the picture of column. If your concrete is not flowable, cannot be compacted easily, and your concrete is prone to segregations, this is really one good example of what happened to your concrete if all those conditions are not fulfilled. So segregation can happen over here. Improper compaction can also happen over here. Or a non-flowable concrete also can cause this kind of condition. The next example, your fresh concrete must be able to be finished nicely or perfectly. In this picture, you can see the before and after condition after the finishing activity has been done on the concrete surface. Here is before and here is after. So now you have like 1, 2, 3, 4, 5 and 6 requirements. If we want to combine all these requirements into one word, then you can come up with one term that is called as a workability. So if you combine 1, 2, 3, 4, 5, 6 requirements all together, you will get one specific term called as a workability. You will use this word a lot to describe the fresh concrete properties in this subject later on. So what is the workability based on these 6 requirements? It means the ability for your fresh concrete to be worked on, particularly for the fresh concrete to be mixed, to be placed, to be cast, to be compacted, and to be finished. So what are the factors that affecting your concrete workability? I have a detailed explanation on these factors in the slide, so you can always refer to it later on. And in here I will give you a summary of the key feature of each factor. The first one is water content. Water is the main lubricant in your concrete proportions, so it will significantly affect the workability of your concrete. If you have too much amount of water, the workability will be too high and may lead to the bleeding and segregations. While if you have a very less amount of water in your concrete, then your concrete will be too dry and you cannot easily mix or compact your concrete, which will be a bit troublesome later on. So the good one is to have the most optimum proportion based on your mix design. The next one is your mix proportion. Based on your mix design, you will get the approximate amount of cement, water, fine aggregate and coarse aggregate. So these 4 items must be in a good proportions or a good balance, so you can have the required workability as per your design. This too is normally referred as a water-cement ratio. If your water-cement ratio high, then you will get high workability, but low strength. If your water-cement ratio is low, then you will get low workability because the proportion of water over cement is low. It means you have less water but high strength. The next factor is on the aggregate properties. Aggregate proportion in concrete takes about 70% of the total volume. So the properties of the aggregate will significantly affect the properties of the fresh concrete and the hardened concrete later on. How the aggregate can affect the workability of fresh concrete. Let's say you have a gravel and crushed aggregate. If you are comparing these two materials, gravel versus crushed aggregate, which one you think will be having a better workability if it is used in a concrete? The correct answer will be gravel in terms of workability. But if you're talking about strength, crushed aggregate is the winner. So what are the main features of these two materials that significantly differ from each other? The answer is in the interlocking mechanism. If you are using gravel in your concrete, the smooth and round properties of gravel surface make it easier to move around during the mixing of the concrete. While if you are using the crushed aggregate in your concrete, the sharp and irregular particle of crushed aggregate make it harder to move around because of the aggregate particle tend to interlock each other. So it cannot easily move around during the mixing of the concrete. That's why the workability of gravel is higher, but because of the interlocking also, the strength of the crushed aggregate will be better. Another condition is saturated surface dry and dry aggregate. If your aggregate is already in SSD conditions, when you are putting your aggregate into the mixture, then your aggregate will no longer absorbing the free water from the mixture. It's different when you are using dry aggregate. The dry aggregate will tend to absorb any moisture given to them. So if you have these two materials in your concrete, workability will be higher in SSD aggregate and lower in dry aggregate because of the water absorption mechanism. What about the strength? It's quite hard to judge the strength performance of these two materials because the strength will be also related to the amount of water and also the cement content. But theoretically, SSD will give you better strength performance than dry or wet aggregate. The next factor is time. Time is playing the crucial factor over here because the hydration of cement takes time. Eventually, your concrete will be hardened later on. But how fast or how long the hydration takes place, that will be the questions. Sometimes you need the extra time to deliver your concrete. So I use this example a lot. If you have a concrete delivered from the batching plant to the construction site, if the distance is too far, then the truck mixer will take time to reach the destinations. In this case, you may want to use the retarder to delay the hydration of your concrete. So by the time the concrete has reached the construction site, it will be still in the perfect condition to be compacted or to be cast. Factor number 5 is temperature. This temperature is directly related with the evaporation of water from the concrete system. If the temperature is too high, the water will easily evaporate from your concrete system. What happens if your concrete is lacking adequate amount of water? The first one, your concrete may not develop the strength as designed because there is insufficient amount of water for dehydration to take place. The second one, your concrete may experience thermal cracking. The next factor is characteristic of cement. Let's say I have a beaker with full amount of water inside it. At the left side, I have coarse cement particles, while at the other side, I have fine cement particles. From these two types of cement, which one you think will be dissolved faster? The fine particles will be dissolved faster in the water. So that's why for a specific type of cement that needs rapid hydrations like RHPC, rapid hardening Portland cement, the cement particle will be finer as compared to the ordinary Portland cement to allow the rapid hydration happen, thus the cement can react faster. And last but not least is the use of admixture. You can name several admixtures that will affect the workability of your fresh concrete. Let's say you can have the accelerator, retarder if you want to delay the hydration of cement, and super plasticizer if you want to produce concrete with a high strength but better workability. So that will be all for my lecture today. I hope you can gain some knowledge from it. If you have any questions, just reply to my post at author.uthm.edu.my. Okay everyone, Assalamualaikum and very good morning. Stay safe at home.